Well, can we start? We will talk about the monsoons, the global monsoons, and then some aspects of some specific monsoon regions. So this is a result of the AR5 assessment report, and where it's plotted the regions of the global monsoons and the changes that can happen in these regions. And these regions are obtained by the difference of the summer and winter. And if the difference is above 2.5 millimeters per day, then this is related to a monsoon region. Okay? Because in the past, the Indian monsoon and the Asia monsoon, they were related to changes in wind direction. Well, today they are still analyzing these changes in wind direction. But there are other regions of the world where we don't have these changes in wind. We have the changes more in precipitation there than in wind direction. When we do the anomalies of the wind, we can see this reversal of the winds. But then this figure is made with this precipitation changes from summer, from the winter to summer. So these are the global, and we can see the Asia monsoon here, the area, the Australia monsoon, the African monsoon region, South America and North America monsoon. And this black line are the observation in the historical period, which is 86 to 2005. And the light blue colors are representing the historical period, the area of the historical period. And this dark blue are the regions where there is an increase of these areas compared to the historical period. And the yellows are the regions where there is a reduction. Sorry. So the main result we can see in this figure here, which shows the global average of all these monsoons and what are the changes. So here is in percentage of change or days, and these are showing these four scenarios. You know, this blue, dark blue is the scenario 2.6, you already know, and the red is scenario RCP 8.5. And this is the global monsoon area. So if you look at this, we see that in all the scenarios, the global monsoon area is projected to increase. And with relation to intensity, all the scenarios are showing an increase as well. with relation to precipitation, global monsoon precipitation, all scenarios are going to project an increased precipitation in the monsoons. But we see that the 8.5 is the increase is very large compared to the other scenarios. And here is the standard deviation of precipitation that is showing an increase as well. And SD1, SD2 is showing the number of days with or the precipitation of wet days, and then this precipitation is increasing as well. And here is the precipitation in 5 days, increasing, and the consecutive dry days increasing as well, and the duration of the monsoon that is increasing also. So if we look at the global, we see that in the average, all these indexes are increasing. We can think that with more water vapor in the atmosphere, we could have more, the hydrological cycle is getting more active, so the precipitation, the area where the differences are larger, all these features are really increasing. So it's consistent with the warming. But if we look each region separately, we will see that some of these index don't show an increase in all members, and then the dispersion of the models are very large, but depends on the region. Let's see. Here we can see all the monsoon regions: the North America monsoon, South America, North Africa, South Africa, South Asia, East Asia, and Australia monsoon. So there are these monsoon regions here. And you see, if we get East Asia, we see that all these extremes are showing an increase. And here is plotted also the onset of the monsoon. That is one interesting thing, and someone yesterday talked about the onset of rain season in Africa that is changing. And then this information is very important. And then we see that in this region, the onset has an earlier start. And the duration, this is because, and the demise is increasing. So the duration of the monsoon increases. You start earlier, the monsoon, and finish later. So the duration is bigger, is larger. And the other, for example, south of Asia, we see here an increase of average precipitation, the same, an increase of standard deviation, the same feature that we see here in East Asia. The only thing is that the onset and the duration, the changes are not so large as in Eastern Asia. But we see that there are some agreement among the models. And in this part, we see the change, the global change in the region, the average. And we see it compared with the 4 scenarios. And when we go to Australia, we see also an increase of precipitation, average precipitation in this region, an increase of the standard deviation, increase of this precipitation days, and these 5 days, consecutive days, also an increase, and consecutive dry days. But when you go to the onset, there is larger uncertainty than the other 2. And but the demise has more agreement among the models, so the duration is high as well. And when you go to North America and South America, we see that for the North America, we don't have too much consistency among models related to precipitation. Related to the standard deviation, large part of the models can show an increase, but some of them shows a decrease. You see that this behavior is very different from the Asia monsoon. The Asia monsoon changes, all the models agree more than in the Americas region. But when we go to the 5 days of precipitation and consecutive days, we see that there is an agreement in the models. So the 5 days is showing that this precipitation is concentrated in some periods, because these periods of 5 days are showing this increase, and an increase of consecutive days as well. But the other, for example, onset and the demise, there are larger uncertainty, because some models can show an increase and other models a decrease. So when you do the average, you end up with nothing. And there is some models show an increase, other models show decrease, and then the uncertainty is related to this kind of non-agreement. And then the duration also has some uncertainty. And when you go to the South America monsoon, it's the same. We see here the standard deviation increase in the majority of models, and this extreme indexes increases as well. The precipitation of the wet days, the rainy days increases, and the 5 days precipitation increases as well, and the consecutive dry days increases. This should be finishing here. But the onset and the demise, there is no agreement in the onset or demise and the duration as well. So we can't say that the South American monsoon will start earlier or later, and if it will be a larger duration or shorter duration. So that global that we saw, that all the indexes are increasing with the global warming, this is because of the strength of the changes of the Asia monsoon in all global monsoon regions. These are the changes of the integrated water vapor in the atmosphere. Because we know that with the warm temperature, or with this global warming, there will be more evaporation and more water vapor in the atmosphere. So there are some regions with convergence of humidity and other regions with divergence of humidity. And this we can see here. The convergence are in yellows, and we see here and here, and all these regions here, and the divergence in these other blue regions. And only to show how the model, one of the model that I told you that Hadjane 2 is showing good results for South America. And then here is the difference of summer, less winter in the South Hemisphere. But you can do North Hemisphere summer, less North Hemisphere winter. That would be the opposite colors here. So this figure shows the South America monsoon and North America monsoon. This is the result with the observation, GPCP, and this with the model. So the model can represent quite well these regions of the monsoon. And the changes in the American monsoon. Here we are looking only one model, because in the other figure that I showed all the models, that one represent an increase, another a decrease. But here we see that in this model there is the shading is the period of 86 to 2005. And the future period, which is 2075 to 2100, is in the contour. Therefore, we see that there is an expansion. This model is showing an expansion of the South American monsoon area. But the intensity, this blue here is 9, and this is 9 as well. So the intensity is not changing too much. And this is the difference of humidity flux during this period, future minus present time, at low levels.
Why the model is simulating these two peaks in precipitation in the core of the monsoon, like one in Peru and the other more towards central eastern Amazonia or central Amazonia?
Yeah, this is the difference of precipitation of December, January, February, and June, July, August. So the difference of precipitation will show the places or there is more precipitation or less precipitation, because it's not uniform. So this is why we have these two centers there. And another thing we can see is in the southern Chile, because the difference in summer, less winter, because in the winter rains more in that region. This is why it's negative there. But it's very interesting that it appears very strongly there. Yeah. Then this is the global features of the monsoon and also some of the modes of variability. And this is in this assessment report. And here is plotted the monsoon regions in white. And the colors are the climatological annual precipitation. We see this South Atlantic convergence zone. We see this South Pacific convergence zone. We see these regions here, that is the storm tracks, where we have more precipitation, because this is annual. And this region where we have strong precipitation as well, and the IPCC, where we have large precipitation, and we can see here the regions of the subtropical highs, where there is subsidence of the air, and there are dry regions here, and the Sahara region. So there are many features we can see in this figure, and these are showing, these arrows are showing the storm tracks, okay, in the north and in the south. Now let's see what is the impact of these modes of variability that we saw related to North Atlantic oscillation and North Atlantic, South Atlantic mode, and the Southern Oscillation Index. Here is not plotted the North America pattern and the South Pacific pattern, the PSA and PNA. But let's see what happens with the temperature and precipitation. Temperature is in this side. So in the North Atlantic oscillation, in the positive phase, we have warm in this region. And here we are not showing all the anomalies, but we can remember what was the pattern of North Atlantic oscillation. When there was positive phase, the storm tracks will be displaced northwards. So the southern part of Europe is warmer than normal. But we see that there is also some anomalies in other regions. Okay. This is the pattern of El Nino with the Southern Oscillation Index. And when this is negative, it means the El Nino phase, because this index is the difference between sea level pressure anomaly in the east side with the west side. So when there is El Nino, the pressure anomaly is negative in the east part. Okay. So this is related to temperature, and in December, January, February, and June, July, August. And here is the sum, the southern annular mode in this season, September, October, November, which is a season where this mode is more intense. And then we see that there is some impact of temperature in the extreme south of South America and also in the polar regions. And there is some signal here in South Africa as well, and some in Australia. What happens with precipitation? So here we have, for the North Atlantic Oscillation, we have positive precipitation to the north and less to the south in the Mediterranean area. And related to this index of El Nino, southern oscillation, we have more precipitation in the Central and Eastern Pacific and less precipitation in the Indonesian region. And this kind of influence can have an impact in other places, like in the North America continent and South America continent, because of that wave trains that we saw in the Pacific North America pattern and the Pacific South America pattern. If we have if we have anomalies here, this will affect these patterns. They can be intensified or disintensified depending on the convection in these regions. So if the convection is displaced to the Central Pacific, the wave trains will be displaced as well, because all that centers are triggered by a spatial location in the tropics. And then what happens with the precipitation in the southern annular mode? Because in the positive phase, we thought that the storm tracks are displaced to southwards. So there is positive anomalies of precipitation in the south, near the pole, near Antarctica, and negative anomalies in southern South America. And in that study we did with this precipitation extremes in South America, we see that there is a positive here that is showing a little bit in the southern Brazil here. And we see also some impact over Australia with more precipitation in this region. Okay. And this is related to this changes in the jet streams and in the storm tracks. So I think that is, yeah. Well, let's see how we're going here. Yeah, it's okay. Well, as a summary, we have seen the main modes of variability ENSO, the North Atlantic Oscillation, Pacific North America, Pacific South America, the North Annular Mode and Southern Annular Mode. There are more modes of variability that I am not showing here because there are not, some of them are not still or are being studied to see if the models can reproduce. For example, we have one mode of variability that occurs in the tropical region that's called Madden-Julian oscillation, which is an oscillation, which is a mode of intraseasonal variability. And it occurs from the Indian Ocean through all the tropical region. And the convection over Indian Ocean and Indonesia, and this pattern of this mode moves to east and then affects some places like tropical Brazil and up to Africa. So these are intraseasonal modes. But the models, recently, some of the models can reproduce this pattern. But the majority of models can't reproduce. So we can't say anything about the future projections, because if the models can't reproduce at the present time, we can't say anything about the future. And as I said, there are other modes of variability that we are not showing here. I showed here mainly the modes that we discussed in the chapter 14 of this assessment. But there you can read about, for example, the Madden-Julian oscillation and Pacific Decadal oscillation, Atlantic multidecadal oscillation that occurs in the sea surface temperature in the ocean. Well, we see that the models can represent these patterns, at least these patterns. The models can reproduce. So this is a good thing. We can see in the projections how they behave. But as I told, there are still some uncertainty in the results. And then we need to analyze more, and we have to have more studies about these patterns to see if they agree in the changes in the future. So the models have been improved along the time, and each time the models are improved, the researchers are looking to see if they can reproduce the patterns better and better, to see if we can say something about the projections. And nowadays, what we know about the projections is that there is large uncertainty in the North Atlantic Oscillation projection, as we saw. Even if we saw that there is a slight positive trend. There are some, the majority of models can show a slight change, but there are lots of models that don't show this increase to a positive phase. Related to the North Annular Mode and the Southern Annular Mode, there is a trend in the projections to positive phase. And this is related to this displacement of the storm tracks, northwards and southwards. So this is consistent with the wind changes that we are seeing. With relation to PNA and negative and PSA. We don't have too many studies about the projections of PNA and PSA also. Have few studies about these two modes. But in the observations, we see that there is a positive trend in PNA. And the positive trend in PNA means that we'll have that ridge over West North America and a trough in the southeast of North America. So this is a pattern of positive phase. And this means temperatures higher in the northwest and temperatures colder in the southeast. And more rain in the southeast and less rain in the northwest. And in the PSA, we have a negative trend related to that phases. The negative phase will increase. No. The observation showed that there is a negative trend. That means the negative phase is occurring more frequently. And what this means, that the center of PSA is one region where we have high pressure there. And it's related with blocking also, because it's a region where we have blocking situations. So it will have an impact also. And we saw that there is, in the projections, we see changes in the position and intensity of the centers. But as we have few studies, there are larger uncertainties also with relation with these changes. And with relation to the monsoon, it's not here, but we can say that when we talk about the global monsoons, the areas will be expanding more in the Asia region. Some models show an expansion in the South American monsoon as well, and some extremes are increasing. I think that all the models show that in the monsoon region, the consecutive dry days are projected to increase. And the extremes in a 5-day period also, there is this projection of increase. So more concentrated increases of precipitation in some periods, and the periods of dry days in these monsoon regions. So it's really the extremes. The extremes will become more extremes. Okay. So now, to have a discussion, if you we have some questions, but then you can take that paper we gave yesterday to discuss this second part of the lecture. Do you have any question for this monsoon? Oi? Ah, então, acho que todo mundo... Não, eu estava tentando achar isso aqui. Acho que... ver se alguém... by the way, there was... I don't know if you noticed it. There were some publication of a glossary, but it's in Portuguese. So the people who want to take, I think that is only helpful for Brazilian people that can read, or South America maybe. And the other one is an atlas. There are only four books about this, but it's only in São Paulo. It's an atlas of São Paulo changes in temperature and precipitation. So the people who lives in São Paulo state can take this atlas there. Okay. There is one question here.
You have shown that in many parts of the world, the monsoon region will increase. The coverage of monsoon region will increase. So, if we want to assess by using models, in what variables we should study? Is it sea level pressure or something else?
Yeah, here, let's see. Yes, you see South Asia is, India, monsoon region is here. Yeah. South Asia, yeah. And we see that there are agreement in the models in many of these indexes. And but consecutive dry days, I think, is the only one that we don't have too much agreement. But related to the duration and the onset and the demise is starting in the projection, starting earlier and finishing later. So the duration is increasing as well.
I actually want to know the spatial coverage. You have told me the spatial coverage of monsoon is increasing. So how can we study that?
Okay, you can have a map with the difference between summer and winter. For that will be June, July, August, less December, January, February. And you can plot this in shading. And then you do the same with the projections. You do this difference in June, July, August, less December, January, February, and then you plot in contour, like I did with the South America monsoon. So you can see if there is a special thing you should do. You need to plot only the values above 2.5 millimeters per day in both periods. So you get an information where it's reducing or expanding.
Thank you.
Thank you for your presentation. I have a question about the Pacific South American mode and how the trend along the impacts of warming would impact precipitation in South America, particularly the Amazon northeast and also southern South America. So can you just summarize that again, because I didn't quite follow the conclusion.
Yeah, well, with relation with this pattern, as I said, there are not many studies that show these changes. there are a few of them that show the difference in position of the centers and the intensity of the centers that probably will have an impact in south and southeast, because this pattern affects very much this South Atlantic convergence zone, for example. And this intensity can impact. But this is only a study with a few models. So it's necessary to have more studies and more models to see if they agree or not.
When it impacts with more intensity in the south of South America, how will that increase precipitation, or what will be the impact on precipitation?
Yeah, over South America, there is an opposite impact in the south and southeast. There is this kind of dipole of precipitation that is related with this wave train of PSEA, because these alternate centers in the PSEA gives, for example, a trough and a ridge. And the trough is related to the upward water and to the atmosphere and convection. And the ridge is related to subsidence. So these two centers are related to places where we'll have more precipitation and less precipitation.
Okay, thank you.
Hello, thank you for your presentation. I have a question about like the global monsoon area. So it seems strange to me that it's like or it's monsoon area or it's not monsoon area. Like we have a criteria, we apply it like for each years on a period of, for example, 20 years. And if most of the time it's considered like monsoon, like the criteria is fulfilled, it's considered monsoon area. But wouldn't it be interesting to study like the strength of the phenomenon, like not having 0, it's not monsoon area, or 1, it's monsoon area, but have like a number between 0 and 1. Mm-hmm. Like for example, 0 is it's never monsoon area, 1 is it's always monsoon area, and like 0.5 it's like half of the time it's monsoon area. I don't know if it's interesting like to study like the strengths. It's not like the strengths, like for example more precipitation, but just the number of time it's considered like the strength of the presence of the monsoon. I don't know if it's clear.
Yeah, I think that's a good idea. I don't know, maybe there are some studies that consider this criterion of one, you have to do a rate of the precipitation in relation to the summer and winter. And then you have this index of 1, 0 to 1. It's a good idea. I think maybe there are some studies that show this, but I'm not showing this, but it's a good idea. Yeah.
Okay, thank you.
I have a question regarding the precipitation change in this part of in tropical South America, because when you look at the trends, the change in precipitation between the present and the future, the models usually don't agree well, so you don't have the hatch there in tropical South America, so you don't know if it's going to really dry on average or to get wetter. But then with the monsoon strength, we get that it's going to get wetter somehow, or it's going to get more stronger monsoon, and I associate a stronger monsoon with getting wetter somehow. So I know that the difference is in the seasonality, but how you conciliate the two views that the models give?
Yeah, you see that what I showed with one model only was the expansion to the east and to the south. In the Amazon region, stays the same. It's not changing that part. And also in relation to the precipitation, there is an increase when we saw the changes in precipitation. There is an increase in the west part and a decrease in the east part. And we see that the South Atlantic convergence zone, that is also part of the South American monsoon, is projected to displace to southwards. And this is consistent with the high pressure Atlantic high pressure that's also projected to be displaced southwards. So if you have this flow that comes from this subtropical Atlantic high displaced to southwards, the convergence is also southwards. So it seems that's consistent with we are seeing in the precipitation related to the South Atlantic convergence zone, and related to more precipitation in the south, and also related to the negative precipitation to the east side of Amazon, but the west side will the precipitation will increase in the west side, but the area would behave the same as in the present time. This is with this. We can see it in the here. We can see an expansion here and an expansion here. That is the same that I showed here. You see, there is an expansion here, an expansion here, and also a little bit here. Okay. So, okay, one more.
Okay, thank you for your presentation. I want to ask you something about teleconnections between monsoon systems. For example, the North American and South American monsoon system. There are some works that study the connection between the frozen equatorial flow. And is there any agreement that it is going to change under climate change scenarios?
I didn't show here, but I did a study with the Hadley Center, HADGEN 2. And we see that there is, in the projections, stronger humidity flux directed to the north, to the North American monsoon, and also to the south in the South American monsoon. So these humidity flux are going to increase with the change. This is one model, but we have this information.
Thank you.
So now we have to see these questions of this lecture 2. So the first one, I think you got the main information. What are the main modes of variability in the globe? So, one, El Niño. Another one, who? Here they are saying NAO. What is NAO? North Atlantic Oscillation. Yeah. Another one. The annular modes for North America, for North Hemisphere, for Southern Hemisphere. Other one. Monsoon. Yeah. Asian monsoon, but it's not a mode of variability. It's, well, we can't say, but the modes of variability, we are calling the modes that have some patterns in the atmosphere or in the ocean that have opposite phases, positive phase, negative phase. And the monsoon is a special kind of variability. Yeah. And there are some Pacific North America and the other one, Pacific South America. Yeah. Okay, then you can remember this and about the modes of variability, okay? Now, this question is important for looking at the impacts. What are the modes of variability that affect your country? Well, let's start for South America. ENSO, yeah. PSA, yeah. Pacific South America, that you saw, that has influence. What else? The annular mode, the southern annular mode has influence also. And in North America, I know there are some people there from North America. Where? Yeah. What mode do you think is affecting North America? Say there in the, yeah.
Well, I know that this isn't exactly your question, but so I live in the southwest of the U.S., and people have been arguing a lot about the monsoon for the southwestern U.S. and whether or not climate change is exacerbating it, is intensifying it or not, because we have decreased snowpack, which means that we have more energy that we're receiving on the continent there. But people have also been debating how sea temperatures rising may actually increase the monsoon. So I know that doesn't exactly answer your question, but that's what I know.
Yeah, about the sea surface temperature, but about the atmospheric modes.
Right.
What mode do you think that will affect the North America that we saw here?
Yeah. Well, the Pacific Decadal Oscillation affects the western U.S. a lot, but so does El Nino, La Nina. All the oscillations affect my region.
Yeah, but who else is from North America? I think there was another person, no? Well, someone there can talk about other modes? Yeah.
Is the answer you're looking for the North American oscillation?
North American oscillation is affecting,
yes.
We saw here,
yes.
That's affecting temperature and precipitation.
Okay.
And other modes.
That's the one that I'm familiar with. Pacific Northern American Oscillation, the PNA.
Yeah, PNA.
Yes.
This is what we showed here.
Okay.
Okay?
Yes.
So, yeah, okay. Let's say Australia. Is somebody here? Australia.
Yes, I'm the only Australian here. So, El Nino impacts Australia significantly, the El Nino Southern Oscillation, causing drought across the country. And I suppose the southern annular mode also impacts Australia to some degree, but I can't tell you exactly how.
Yeah. Okay. And let's say Africa? Someone? Let's say, what is your region? North, center, or south?
East Africa.
East Africa.
Yes.
So, is in the tropics, isn't it?
Yeah. For East, it's Enso.
Enso.
Yes.
Yeah.
Yeah, because of the Indian. Okay, it's Enso, which has been actually scientifically documented that it is going to. Yeah, it's for the variability of climate, showing that short rains will between the short rains of October, actually of Ondi, will bring about wet conditions in the region. So.
And
that is for East Africa. So I don't know for West. There is West Africa, Central Africa, Southern Africa.
Yeah.
I think we go to Southern Africa.
Yeah. Well.
Yeah, I think for Southern Africa, I think it's the Southern Oscillation and El Nino, and the El Nino is associated with drought conditions, and the La Nina is usually associated with the high rainfall.
Yeah, the North Africa, I think the Atlantic Ocean is very important to that region. And we didn't talk here about the SST in the Atlantic because there is a mode or two modes, main dominant modes of sea surface temperature in the Atlantic Ocean, which is the north-south gradient that sometimes is called the dipole of SSTs in the tropical region, and also a kind of El Nino in the Atlantic, that there is anomalies, positive anomalies in the east part and negative anomalies in the west part. So these modes that we are not showing here because there is not projections about this in this report. So these modes can also have an impact in the precipitation of North Africa. But there is another one that can have an influence, and we showed here, that's related with the trade winds. That I said, this intensification of trade winds and the weakening of the trade winds, this both have an impact in the position of what? The IPCC. So the IPCC has an impact on North Africa as well. Okay. Siberia. What is?
So what I think about this question, that, for example, North Atlantic Oscillation will not affect this region because it's blocked by the Ural Mountain, and so this oscillation is not work. Also, this territory is blocked on the south by the Himalaya Mountain, so El Nino also don't work. And we have only two. This is the Pacific North America and the Northern Annular Mode. So only a little bit of these two modes.
Mm-hmm. Yeah, that's right. And what other region would like to see? Indian region.
The most dominant mode on India is the ENSO, and it has a negative correlation with the monsoon rainfall of India. However, there are some studies which have suggested that after 1990, the link between Indian monsoon and ENSO has been weakened. And in the some part of the northwestern part of the country, there may be some influence of NAO.
Yeah, and there is another mode in the Indian region that's in the Indian Ocean.
IOD.
That is a dipole of Indian Ocean, and we didn't talk here as well. But that mode has also an impact on the precipitation of Indian region. Okay. And Central America, someone from Central America would like to say something?
Hello. Well, from Central America, the most influence is Del Niño, and this is for the part of the Pacific. But in the Atlantic, some studies, not in Guatemala, but in other places, the North Atlantic subtropical high pressure system, the NASH, can do some influence there.
Yeah. Thank you. Is there any region I forgot to ask? Please be free to talk about. No? Okay, so let's say the third. How the extremes will affect your country? I think we saw here that the extremes, the increase of extremes will affect probably all countries will be affected by the changes in the extremes, because more precipitation or dry conditions both are impacting maybe all the countries.
I want to ask, could you explain a little bit more about the region of the monsoon in Chile when you show the pole?
Yeah, well, that's not considered as a monsoon region, but there is a difference. The only thing is that, you see, it is an opposite of a monsoon region, because the monsoon regions are considered as the regions where the precipitation in the summer are greater than the precipitation in the winter. So in Chile, as the precipitation is larger in the winter, because the storms are going to that place more frequently and with more precipitation, then we have the opposite. This is why we see a signal here. But the monsoon region of South America is this one here. And this behaves like the other, you see. Pardon?
It has a name, this behavior?
Name?
Non-monsoon word.
Yeah,
I don't know. Is the PDO or anti-monsoon or something like that?
I don't think there is a name. Probably there is not a name. Yeah, but it's an interesting feature. Yeah.
And the PSCA, between the PSCA and the El Niño, what do you think is well, I think that it is the ENSO, but I am not sure is the more important influence on that region.
The El Niño trigger these wave trains. So the only difference from El Niño to the other years is in the position of these wave trains. Because in the normal years, the convection is triggered from one place in the tropical region, and that PSCA is affecting South America in one way. And then when this convection is changed from west to east, the PSCA is triggered as well, and the centers are influencing other regions. So both are related. We can't say that it's PSCA that is influencing or El Niño, because they are related.
Just to add something, I live right in the center of that Chilean anti-monsoon. And according to my understanding is that there will be because it rained mostly, the annual total is dominated by the winter. Mm-hmm. So it will be a reduction in, especially I think, year-round precipitation, because the storm tracks are going to weaken and move toward the south. So that's why basically we will have less precipitation there, and likely that's why the seasonality is, because it is dominated by the winter precipitation reduction. So I think that explains that.
Yeah. Okay. So let's see how we can. And the projected change of monsoons. We thought that the global, when we consider all monsoons, we see that all features are increasing, like the area, the intensity, the precipitation, and the extremes. But when you go to each of a region, there are some difference that we have to take into account. Okay.
Just a small question about the PDO. Does it influence also this region of South America? In which way?
Yeah, because PDO is, although it's a North Pacific oscillation, the southern center coincides with the El Niño region. So these phases, when there is a positive PDO, the anomalies are increased in that region. So this has an impact in other regions that are affected by El Niño. So yes, it will be affected. Well, we are ending our lecture, and I hope you have got information to follow the other lectures, but this is the basic information from the science, the atmospheric and ocean and earth system science, and I hope you take the most of this information. Okay, thank you very much.